What is the main definition of the gate?
The passage for the part
Yeah, you can
flow the
yes.
material.
So you can say that it is basically it is exists between the component and the sub runner, right, or the main runner. So basically it will join this runner and the component together, right? And because of the gate, there is a mark on the component, right? For example, if you have a physical component, you can see the gate mark. Where is the gate mark? You can see the gate mark, right? Right. Now see, gate selection and the calculation. So there is a two things here. First is the selection and the calculation. है ना? First is the selection and the calculation. Now see here. Gate selection is depending upon three things. First is appearance. Achha, what is the meaning of appearance? It is about looking of that component, right? How it's look. Appearance of the component. है ना? Second one is application or the uses you can say, right? And the fitment. What is the meaning of fitment? For example, you have a bottle like this, right? And for this bottle, for this header, you have to design a cap, right? So there should be a fitment between this component and this component, right or wrong? This is the fitting, right? So this will become male part, this will become female part, right or wrong? Understood? So gate selection is depending upon three things: appearance, application, and the fitment of component with its assembly. Okay, so first of all, see the appearance of the component. What is the meaning of appearance? First of all, if we are dealing with the plastic material, so you can say that appearance should be satisfied for the customer, or you can say that for anybody. You can say that, for example, if you are purchasing any bottle, right? So if there is a three bottle there in the shop, there is a three bottle in the shop, and all three bottle are the same. All three bottle are the same, but there is a defect into this component, and there is a mark into this component, and there is other mark into this component. But fourth bottle, same company, you can say that, but fourth bottle is looking nice. So you will select this, right or wrong? So that's why appearance is very important, right or wrong? Understood or not? Tell me. Generally, if I am talking about the plastic material, so basically we have to deal somewhere, we have to deal with the household product or the kitchenware product, right or wrong? Okay, right? So you can say that it should be look like a wow, है ना? If I am talking about the household product, or if I am talking about the automobile component, right? So it should be shine there, right? Understood or not? Okay. Acha. Application of the component. See here. Please reply me. My voice is clear? Screen is visible?
Yes, sir.
Yeah. Second thing is application of component. Now see. Application. What is the meaning of application? That where is component is used. You can say that where is the application? In which field there is an application of that plastic component. Right? Okay. Now it is also depending upon, for example, if you are designing a component, or you are designing a component for medical, so depending upon that medical application, we have to choose the material also, right? For example, if we are designing a component or plastic component for the household product, or for example like a toy, for toys, right? So depending upon that toy or the household product, we have to choose that material, or depending upon that material, we have to design the mold. And if we are designing the mold depending upon that particular application, right, depending upon that, we have to take the gate selection, right or wrong? Understood or not?
Yes, sir.
Okay, see. Okay, understood. So depending upon the uses, that where is the use, and where is the use of the component, right? Okay, now fitment of the component, for example, with its assembly. For example, if you are preparing plastic component like this, see here, and or here you can see that in this component. 1 minute. For example, this is this. For example, and you are giving the gate position in this position. So what is the problem will occur here? Tell me. What will be the problem? It will create the restriction for this, right? It will create the restriction for this. Okay, so that's why fitment should be satisfied with its assembly part. Okay, for example, if we are dealing with somewhere a complete machine, okay, which is the combination of 4 parts. Okay, so one part or the other part should be fit in each other in a proper way, right? So there should be their fitment should be satisfied, right? So it is basically here we are dealing with the dimension accuracy, right? Dimension accuracy. Understood? Okay? I think quite understood about this, right? So gate selection is depending upon the gate selection, or the calculation is depending upon 3 things. And selection is depending upon 3 things: appearance, application, and the fitment. And apart from these 3 things, we have to discuss with the customer also. Okay, where should be the for example, if customer provide you a component of the plastic, if customer provide you a component, so you don't know about the what is the use of this component and what is the application of this component. So customer said you, right, that's all, you have to take the gate position at the edge or the top or the bottom, right or wrong? The customer will suggest you about that. The customer know what is the application of that, right or wrong? So that's why we have to discuss with the customer about that. Understood? Okay. Gate design points to remember. See here, for example, gate design points. So if we are designing a gate, so it should be easily removed. It should be easily removed first, and second one is that multi-cavity mold should be balanced. If we are dealing with the multi-cavity like 2, 4, 6 or the 8 component, so it should be balanced. Easily removed means, for example, see here. So here I am showing the gate which is known as submarine gate, right? This gate is nothing but it is the submarine gate. So during the ejection of the component, during the ejection process, it's degating automatically, right? With the minimum force you can say that. So it should be easy remove. First of all, it should be easy remove. It should be like this, and right. So it is also depend upon the type of use we are using, type of gate we are using, right? Okay. Second one is multi-cavity mold should be balanced. What is the meaning of multi-cavity mold? For example, if we are dealing with the 2 cavity, so it should be balanced in a proper way. It should be both the component should feel in same time. This is very important. Okay, now again, apart from this 2 component, if we are dealing with the 8 component, then all the 8 component should be feel in a same time. Is it clear? So it should be balanced. Understood? Cavity can be 2, 4, 6 or the 8. Now see here gate design parameters. For gate design parameter, I am just taking the example of the edge gate. Okay, right now see. For the edge gate, you can see that here h equal to nothing but height of the gate. Okay, W is nothing but it is like a width of the gate. What is the meaning of that? For example, if you have a component like this, see here. Okay, and here I am talking about the edge gate. What is the meaning of edge? Edge meaning, for example, edge means this is the position of the gate, right? So here you can see that this is the gate here. This is the gate. Okay. So here this is nothing but this is the height. Okay. Or if I am taking the cross section of this, so you will get the cross section like this. Right or wrong? Okay. So this will be the height and this is nothing but this is the width. This is the width, this is the height, and this will be the again height, right? Land, which is the length, which is the length. So from this point to this point, it is the length. It is the length. T is nothing but it is the wall thickness of the component. Now if I am talking about the wall thickness, so what is the meaning of that? It is the average wall thickness. Is it clear? Average wall thickness. N is nothing but it is the coefficient, which is the constant of material. For now I am telling you that it is depending upon the viscosity. I will explain it, don't worry, okay? N is nothing but it is the coefficient or the constant of material. Constant of material, N value. Understood or not? Just I am showing you edge gate right now for the parameters. Okay, now see here. See H, here is the formula. H equal to N into T. And what is the N here? Constant for material. And T is nothing but average wall thickness. Okay. Now W is nothing but it is the width. So once you get the H, which is the height, you will get the W. The W will be the 2 into H. 2 into H. Okay. Now see. L, which is the length. You can take 1 to 1.25 maximum for the edge gate I am taking, right? For the edge gate, you can take 1 to 1.2. Why I am taking this range? Tell me. First point should be satisfied, which is the easily remove, right? That's why. Right? That's why I am taking from 1 to 1.25. And there will be the less mark. There will be very less mark on the component, right? Because of this. Understood? If you have any question query during this slide, please ask me. Okay. See here. This is the top view. This is the top view in which I am showing you few dimensions. Like so for example, this, see here. This is the length. This is the length from this point to this point. Here this is the width. This is the width and this is the T, which is the wall thickness. Here I am showing the cross section of this also. Cross section of this also. See, this is the cross section. Sorry, this is the section view. This is section view. See, so here this will show the height. This will show the height, which is the H. Which is the H. Understood or not? Understood or not? What I am showing in this slide, tell me.
Sir.
Nothing but parameter of the edge gate, okay, which is the very basic gate system, you can say that, right? I am just showing the parameters of edge gate, dimension, you can say that, right? And I have shown you one more thing, which is about the height, which is the height and the width. So this is the simple formula for that, and this is the nothing but this is the range. This is the range for that, right? And here you have confused about the N. That what is the N here, right? So as I told you, this is the constant of material, and I am going to explain, don't worry, okay? Understood? Now see here. See, so what is the N in the design? What is the N in the gate design? See, so N is nothing but, as I told you, it is depending upon the viscosity of the material, right? Okay. So the material constant N is 0.6 for free flowing material, you can say that, such as the PE material, which is the polyethylene. So what is the meaning of free flowing material? What is the meaning of free flowing? Tell me. For example, if you have a three type of bottles, and in this bottle you have different type of liquids, different type of liquids you have, right? Okay. And for example, this is the hole, and every hole has a different dimension. For example, this hole has a 1 mm diameter. How much? 1 mm diameter. This hole has 1.5 diameter, and this hole has 3 mm diameter. Okay. Now depending upon the material viscosity, because of the gravity, this material will flow in from this hole, right or wrong? So this capacity or the flowing capacity is known as the free flowing capacity of the material. Okay, free flowing capacity of the material. But material should be in melted condition. Understood or not? So as I told you, n is nothing but n is the constant value depending upon the material, है ना, depending upon the material, or material has a viscosity property, right? So depending upon that viscous material, this n value will be greater, right? Now see, you can see that here 0.6 for the PE material. PE matlab polyethylene. What is the meaning of PE? Polyethylene. Okay, PS means polystyrene. 0.7 for the more viscous material such as the acetyl PP, polypropylene material, like 0.8 for such as cellulose or the cellulose or the acetate material, like, and 0.9 which is the for highly viscous material like PVC. Okay, so this is not the same value. This is not the, you can say that this is not the separate value, right, of the n. So you can say that, for example, if I am talking about the height, so basically we have to multiply the n with the wall thickness, right or wrong? For example, if I am finding the height, so we have to multiply n with the wall thickness. Understood or not? Tell me.
Yes, sir.
If you have any question, could you tell me? What is the n here? Nothing but it is the free flowing capacity of the material, है ना? If the material in melted condition, so in how much diameter hole it can be flow, right? So this is the free flowing material capacity. Understood? So that's why this is the standard value, as I told you. Understood? So n value for the P and PS is 0.6, as I told you. PP is the 0.7, PVC for the PVC 0.9, right? And understood?
Yes, sir.
Okay, just for an example, edge gate design for 2 cavity mold calculation, right? See here, for example, we have a part 1 and part 2 here. Okay, so we have to design depending upon the part, है ना, depending upon the part weight and the length, है ना. अच्छा, how to decide the runner diameter? Tell me, how to decide this diameter? Tell me. Tell me the formula for the diameter. Formula for the diameter. Tell me. Right? Divide by. You are making notes or not?
We are taking notes, sir.
So this is the formula for the runner diameter, right? Okay. W to the power 0.5 multiply by L to the power 0.25 divided by 3.7, right? Understood? Okay, so you will get the diameter. But if I am talking about, for example, you have a PP material, है ना, PP material, or you have ABS material, for example, right? So if you have this material of component, so what is the range for PP and the ABS material? Tell me, for the runner diameter. 5 to 10 mm. Yesterday we have discussed about this, right? Acha, for
Yes,
the
yes,
PVC,
correct.
yeah, for the PVC, tell me.
Less than 6 mm. Okay. 6 to 16.
Right? Okay. Acha, tell me PU, for the PU, polyurethane. How much? 2 mm to 8 mm. It is the less viscous material, right? We can take, but 2 mm is difficult to manufacturing by the VMC or the CNC machine. That's why we have to take minimum 5 mm or the 4 mm, right? We have to take.
Yes.
Understood?
Correct.
Okay. So here we have a part 1 and part 2, and I have designed the complete runner. Okay, complete runner, which is nothing but which is the primary runner. Okay, here. Okay, this red portion is nothing but it is the gate. So here I am using the edge gate here. Here I am using edge gate. Understood? Okay, so this is the runner. Okay, the red area is the gate location. So mostly you can say that if I am dealing with the household product or the kitchenware product, right, or the for a rough use component, any type of plastic component if we are using, so generally edge gate is used in multi cavity. Okay, generally, is it clear? Okay, see here. So this is the top view of that material is the PP. So I am taking the section view, which is the AA, right? Here you can see that. Okay, this is nothing but this is the edge gate. है ना? Here in the section view, I am showing the height. I am showing the height, and in this top view, I am showing the width right now, right? Or where is the length? From this point to this point. This is the length. How much I can take for the edge gate? Tell me. Length. 1 to
1 to 1.2.
1.25. Okay. 1.25 I can take, right? Okay. See here. Okay. So here wall thickness, for example, wall thickness is the 2 mm. 2 mm. And material constant N. As we know already that for the PP material we have to take 0.7, right? Which is the value of N, right? Now H equal to N into T. What is the T here? Wall thickness, which is the 2 mm. So you will get the H value. What is the H value? 0.7 multiply by 2 mm. You will get 1.4 to 1.5. Basically you have to take the 1.5, right? Okay. Now W 2 into H. Okay, so 2 into 2 multiply by 1.5. You will get W equal to 3 mm. So you got the value about H as well as for the W. Okay, and L you can take 1 to 1.25 maximum, right? You can take. So you will get the gate dimension, right? Acha, now if you have one component, see here. Now for example, if you have one component like this and customer said you, sir, we have to prepare the 2 cavity mold, right? So you can prepare for this component a multi cavity layout. Tell me, you can prepare or not with the edge gating? You can prepare? Yes. For example, this is the center, this is the center. From this point to this point you have to take 20 mm, right? And from this point to this point you have to take 20 mm. This is the another component. So this is the first component, the second component. You will get 20 mm, 20 plus 20, right? Okay, 20 plus 20. So here this will be the runner. Now for example, material is PP. Just for an example, material is PP and component weight has for example 5 gram. How much? 5 gram. This will be the 5 gram, right? So what will be the total mass? Maximum. How much mass it can be? Maximum, if I am adding the runner, so you will get 15 gram, right or wrong? So this is nothing but W, right? What is the length of the runner? 40 mm. 40 mm. So what you will get by this?
Diameter of the runner.
Diameter of the runner, right? Okay, now you know here that wall thickness, average wall thickness is about to 1.5, right? So you know about this and you know the material, that material is the PP, then it means it will be the 0.7 and it will be the T will be the 1.5 and multiply by this. So what you will get?
3 mm.
1.5 multiply by 0.7. How much you will get?
1.05.
1.05. Confirm?
Confirm.
Okay. ठीक है. So you will get H value, right? So basically you will get the 1 mm. You can say that approximately 1 mm, right? So you can get W. So 2 into H. What is the H? 1 mm. So W will be 2, right? So what you are learning here? You are learning the basic calculation depending upon the manufacturing feasibility, right? You are learning the basic calculation, which is very important. Right? So for example, if you are going to complete the simulation. For example, if you are preparing the 2 cavity or the 4 cavity, right? Before that, you have to take the exact or the accurate calculation for that, right? Before the simulation, your design should be calculated, right? before that. Understood? What we are learning?
Yes, sir.
We are learning basic calculation, which is very important. Understood? Okay. Now see the type of gates and its calculation. See, there are this type of gates, you can say that. See, है ना? So direct gate, like edge gate, like overlap gate, fan gate, film gate, diaphragm gate, submarine gate. So this all gates is depends upon its selection is depending upon the component geometry, appearance, and the application. Again, I am telling you, है ना? About the all gate. This is the type of the gate, the direct edge gate. No, अच्छा, what we have, I have show you only about this gate, right? Right now. है ना? I have show you about all parameter or the uses of this gate, right now, है ना?
Yes.
Now see here. So basically it's this all gate selection is depending upon the component geometry, appearance, and application, right? Now see, as I told you, for selection of for the selection of appropriate gate, you have to discuss with the customer, है ना? Which is very important, है ना? Which is very important, right? For example, if you are not discussing with the customer, so what will happen there? For the position of gate, you are not discussing. So what will happen there? Customer will provide you extra revision. It means you have to work again on the mold design. Okay, because mold or the mold design, basically it should be satisfied for the customer. You can say that, है ना? Customer should be satisfied for the design, with the design, right? See here. So see the direct sprue, है ना? What is the direct sprue? अच्छा, we have discussed about the direct sprue in single cavity mold. Tell me. We have discussed about the direct sprue. Tell me.
Yes, we have discussed.
What we have discussed about the direct sprue? Tell me.
We have discussed about the sprue diameter,
And
which should be more than
aperture hole.
half a diameter.
Aperture hole, right?
Aperture hole, yeah.
Yes.
Aperture
So
hole.
aperture hole should be greater than
Nozzle.
nozzle diameter, right?
Nozzle diameter.
Yes. So here you can see that direct sprue, है ना? Direct sprue is used for the single component, है ना? If the component volume or the component area is large, right? So where we have to use the direct sprue, or if we are dealing with the single cavity, that's there we have to use the direct sprue, right? See here we have a component like bucket or the basket, you can say that, right? Okay. So here we have to use the direct gating, sprue gating, you can say that. So this is the sprue. Here initial diameter should be more than machine nozzle. Okay, so the nozzle diameter plus 0.8 or the 1 mm you can take, है ना? 0.8 mm is not the specific value, you can take 1 mm also, है ना? See, draft angle for that, for sprue, it should be between 2 degree to 5 degree, है ना? But for example, if the sprue length is 1 minute. Okay, so for example, but the sprue length is large, like this. Okay, here for example, sprue length is about 230 mm here, 30 mm, but sprue length is about 270 mm here, or more than 40 mm. So in this type of critical condition, we should take 1 degree to 1.5 degree also. Acha, what is the use of this draft or the taper? Tell me. Why I am giving this step? What? Tell me again.
For the easy material flow.
Not for the easy material flow. Because of this draft, it will be ejected easily, right?
Yeah, we can remove the part easily.
Yes, we can remove the part easily. For example, for example, this is the sprue bush. Na? See, for example, this is the sprue bush, and if you are giving the sprue like 90 degree, see, just for an example, see, achha, what will happen here if you are removing this sprue from this direction? Tell me. There will be the friction between these two surfaces, and the plastic and the metal, right?
Yes.
Right or wrong? But if you take the draft, what will happen there? suddenly it will go around 0.1 mm and it will deattach because of the draft, right?
Yes.
It will deattach. That's why draft is very, very important, है ना? तो even here I am talking about the sprue. Okay, if you are designing a plastic component, so in plastic component there is a requirement of the draft for any type of features also, right? For the easy ejection, है ना? You can see in any type of plastic component, so there is a draft which is very important, right? And we have done the draft analysis also in lecture first or lecture second, right?
Yes.
है
Yes.
ना?
You are right.
Yes, okay. So here generally direct sprue is used in household product, है ना? Household plastic component. We are using this direct sprue, है ना? अच्छा, we have discussed about the edge gate here. Where is the edge gate we can use? Edge gate is used for the circular or the square component. Okay, for the circular or the square component. Now again I am telling you one thing, that for example if customer need, for example, as I told you, it is also depending upon the customer, right? And a selection of the gate, it is also depending upon the customer. For example, this is the component you have, and customer tell us and tell the designer, and said the designer that, sir, this surface and this surface is very important for us, and this upper surface is very important for the appearance purpose, right? Just for an example, okay, this surface, 1 minute, and this surface is very important, and this is only the way from where you can feed the material, right? So that's why we have to take the edge gate here. Okay, Archa, understood or not?
If this is the single cavity mold,
No,
then
if this is the single cavity mold, then customer said you that for example you are not going to, you will not you will not take the gate point here, like you will not get the gate point here, right? So then you have to take the another thing, that for example you have a component like this, okay, so you have to prepare the gating system like this. This is the sprue then again, right? And you have to take the nut like this, and you have to prepare the gate like this. Okay, but for example if customer said you that you can take the edge gating system at this point, right? So for that you can take the pinpoint gating system as we discuss, right? But depending upon the application, right? But as I told you, edge gate we can use into the multi cavity only, into the multi cavity. Understood or not?
Yes, sir.
Confused? Quite confused about this?
If you have little bit more examples, please.
So for example, like for example, this is the component here, right? But this is the very small component. Like this component has a weight around 10 gram, right? 10 gram. So basically, we have to suggest the customer that, sir, you should take this component. This component should be in multi cavity. Why? Because if you have a 10 gram component, so why you need this component in horizontal molding machine? Why you need why you need this component to manufacturing in horizontal molding machine? So you understood about the differentiate between the horizontal and the vertical molding machine? Depending upon the short, right? If you have a less weight component, right? So you can prepare that component in vertical injection molding machine, which has a capacity around 20 gram or the 25 gram or the 30 gram, right? So why we are going for the big machine? Why we will go for the big machine, right?
for large components,
Yeah.
number of cavities are more. then
Yes,
we'll go for-
then we will go for the you can say that for the 30 ton or the 50 ton or the 80 ton machine, right? But this type of single component, if customer need to, for that we can use the vertical injection molding machine, which has a around 10 ton capacity, right? Which has a short capacity around 15 gram to 20 gram like this, right? That's why. Understood? Depending upon the uses of the application, right? Now see here. Acha, understood or not? Tell me, Hemant. Understood?
Yes, understood. Understood.
Okay. So here this is the edge gate. And the edge gate, as I told you, where we can use the edge gate. Tell me.
Where the parts are circular or rectangular.
Circular or the square component or the rectangular, you can say that. But depending upon the application of the component also, है ना? For example, as I told you, customer said that this component, this phase is very critical for us. This phase is also very critical. But you can take the gate position at this point, right? If customer suggest us, so we can take here, right? Now see here. Understood? See, so this is the parameters, है ना? So this is showing the height, and this is showing the width, which is about 2 multiplied by h, right? Here this is the L, which we can take 1 to 1.25, right? Okay. So if the component weight is about less than 15 gram, so we can select the edge gate. Acha, understood or not? If we have a component more than 15 gram, then what we have to take? For example, if we have a component like this shape, then this is not the square and this is not the circular, right? This has a rectangular shape like this. The width is, for example, like 50 and the length is about to 120. Then can we use edge gate here? For example, if we are using edge gate, what will happen here? Tell me. Material will go from this point and it will flow like this. It will flow like this. What happened here? Tell me. Weld line will be occur. Right? Not understood. Acha, see here overlap gate. Now see here. Overlap gate. What is the overlap? Now we have a component like this. See. And customer said, for example, this is the critical phase for us. 1 minute. I am taking the another color. This is the very critical portion for us. And this complete phase is very important for the customer. But customer said this is the only position. Where you can take the gate position. This is the only phase where you can take the gate. Okay, so that's why we can use like edge gate. It is like a edge gate, but we will use overlap gate there. How? See here. See, overlap gate is also used for the circular or the square component. Now you can see that. See here, like overlap gate. What is the meaning of that? This is the bottom of the component, right? And your component, your material will be go from this direction. See. So basically, what is the difference between edge gate and the overlap gate?